Hey there, 5.1, Angles of Triangles, the Journal Vocab-Notes-Practice. Getting into triangles. Triangles really big in geometry. They're strong shapes, they're rigid, get used a lot in engineering. So let's go that. So when you look at a polygon or a triangle, interior angles, those are the original angles. You know, these ones on the inside, you can think of it. Angles, oops, that's supposed to be red. Angles inside the triangle or polygon. The original angles, they call them, of the triangle, I believe I saw in the book. Exterior angles. Again, you can think of them as exterior. The triangle or polygon, that's not exactly it. They're formed by extending one side and an existing side. So that's what happened right here. We extended this side right there. Get rid of those in blue. And then that makes I've got the purple right here. That makes that the exterior angle. Notice these form a linear pair. So one way you get the exterior angle is you make it a linear pair to the interior angle. Also, this corollary to a theorem, a direct result of an existing theorem. It's not unique enough to justify its own theorem. Gosh, I was writing really neat that day. I notice when I write neat, it's not common. It means it's related to another rule. It doesn't mean it's not important. But it just means it doesn't have its own name. It's connected to something else. Sometimes you use the corollary more than the theorem. This stuff you probably have heard before. Some of you will know it, some of you don't. Scalene, isosceles, equilateral triangle. No congruent sides for scalene. Two congruent sides. It's at least two congruent sides. Notice that for an isosceles. So technically, an equilateral triangle is also isosceles because it has at least two congruent sides. The marks I mentioned here, those are congruent marks. 1 means congruent to 1, 2 means congruent to 2. 1 is not congruent to 2. This over here, equilateral, implies equiangular triangle. You have one, you have the other. It's like buy one, get one free on that. Equiangular gives you equilateral. Then you also have your acute right and obtuse down here. Acute is 3 acute angles. Right is 1 right angle. The other 2 are acute. Obtuse triangle, 1 obtuse. The other 2 are acute again. I got a little proof here. I'm going to read through this. We haven't done enough proof in 2021 spring when I'm teaching this year because of the COVID, for those of you listening in the future. But proof is pretty cool. It's kind of a very powerful thinking tool. It's challenging, but it's powerful. So we got a triangle here. Okay, with those 3 angles, 1, 2, and 3. We're going to prove that the angles of a triangle can be add up to 180 degrees. So this isn't written very well here. Let me do this and change the color of those because those steps kind of go together. So we know that these angles up here add up to 180. That's the straight angle theorem. I should go back to red. Okay, we know those are 180. From earlier in the year, we've got parallel lines. And if you look, angles 4 and 1 are alternate interior angles, as are angles 5 and 3. That's why they're written down over here. And I got our alternate interior angle theorem over here. Those mean those are congruent. Okay? Now we can do a little substitution. Since angle 4 and angle 1 are congruent, I took out angle 4, I put in the measure of angle 1. I did the same over here with the measure of angle 5. Took out angle 5, measure of angle 5, put in measure of angle 3. Now these add up to 180. And I've just proved to you that the angles of a triangle add up to 180 degrees. Okay? And that can't be doubted. That is a fact. After that. Okay, so there's that theorem right there. The triangle sum theorem. I think it should be the triangle angle sum theorem. A lot of times they have triangle angle sum theorem there. Any triangle, the angles sum up to 180. We're always talking the interior angles, of course, on that. They don't have any exterior ones drawn. There's an exterior angle, but we're not talking about those. There's another exterior angle, but we're not talking about those. We never draw two at the same one. Okay, here's another theorem that's really useful, actually. But most students miss this one and make work harder. Doesn't mean they get the problems wrong, but they just work a lot harder. We've got some proof in here. I'll come back and prove these later if there's time. Or maybe I'll do the proofs in another video. But I can see this is running late already. So, if we're given ABC as a triangle, we're trying to prove that. That's what this proof. We're trying to prove this theorem right here. That these two interior angles, let me mark them like this. These interior angles add up to this angle over here, angle 1. The two remote interior angles sum to the exterior angle. But that's what they're trying to say there. That's not always the easiest one to see, but kids miss that. I got an example of how they missed that. And then we have a corollary here to that. That's why they had that corollary theory term. The acute angles of a right triangle are complementary. Again, we'll come back to this proof in another video, I suspect. So if you have a right triangle, these two acute angles right here, this one and this one, add up to 90 degrees. Complementary means sums to 90 degrees. So they're complementary again. I'm kind of surprised this is a corollary, but that's more me. I shouldn't have these in here because we should work these. So, you know A and B add up to these. So if I know the measure of angle B, let's say this is 43 degrees. I know angle A and angle B have to add up to 90. I can just subtract 43, I get measure of angle A equals 47 degrees. I could do it like this too. I could say, hey, you know what? These three angles add up to 180. But then I'm going to get the same answer, but I'm going to have to do more work. So I have to do this addition here. So I have measure of angle A plus 133 equals 180. Minus 133 minus 133. I got bigger numbers to subtract, so that means there's a better chance for a mistake. So I have to do an extra step. I can still get my answer of 47, but it's more work. Notice we got our scrambled answers again up here. Extra practice. In exercises 1 to 3, classify the triangle by its sides and by measuring its angles. Well, most of you don't have a protractor to measure the angles. We're going to do visual ones. Remember, acute, less than 90, above 0. Right equals 90. And obtuse is between 90 and 180. So let's do number 2. this looks like a right angle to me right here. So I'm going to call that a right triangle. Okay, and these three sides, none of them look congruent to me, so that's going to make that scalene. So we have a scalene and a right triangle. There's my right, there's a scalene. Now if you run out of these, this one you can make some mistakes on, so be careful. If you end up not having enough of one of them, that means you picked something wrong somewhere. Don't forget you got your congruent marks right here. Classify triangle ABC by its sides, then determine whether it is a right triangle. So this is a lot of work on this problem. So you basically have to find all three side lengths. Remember, AB means the length of side AB. I got this started here for you, except for doing a decimal. But you can tell in a lot of places where these are the same. They'll be the same here. A lot of you can't do the reducing. You do need to know that for college and stuff. And then my decimal here. Whoops. Just on my calculator, taking longer than I want. That comes out to 4.24. And I should say that's about 4.24 because I did round it. Okay. I'm using my distance formula. You can see that over here. I started AB. I've got that worked out. I had labeled my points at some point. I don't know what I labeled them here. This looks like X2, nope. X2, Y2, this looks like X1, Y1, and plugged in my points, went through all the work, got those answers in the end. Then I relabeled them for AC. Now, if you label it differently, you'll get the same thing, except it might come out 6 minus 2 here, and 6 minus 2, you'll get the same thing. One gets 4, one gets -4. When you square either of them, they come out to 16, so it comes out the same. Don't worry if you get the wrong sign. So if you get a 3, you get a positive, or I get a negative, that's no big deal. These ones are that corollary I talked about that people miss all the time. So, and it doesn't matter, what numbers are there. It's this angle and this angle add up to this one. This angle and this angle add up to this one. Stick to the simple things when you're looking at those. Don't make it complicated. The numbers aren't important. You're thinking blank plus blank equals blank. I kind of set this side first, but blank equals blank plus blank. Fill those in. Okay? Oh, that's going to be 8x minus 5. This is going to be 40 over here, and you can solve that, and then you can go and find your number up here somewhere. Just remember on this one, after you solve it for x, to find the measure of the exterior angle, you have to plug x in over here, and then that'll give you your answer, which is one of those ones with the little degrees symbol up there. Last one, we're nearly out of time. I'm at my maximum of 15 minutes. In a right triangle, the measure of one acute angle is twice the sum. That means 2 times the measure of the other acute angle, and 30. Okay, so the sum of the other measure of the other angle and 30. The other angle is this angle here, so that's going to be x plus 30 in there, twice that number. Find those, you can plug them in and get the answers. We're pretty much out of time, kids. Have a good day. A little short on number 7. Ask in class if you don't get it.